package indicates that derating the conductor ampacity should be considered when placing 5 to 840-2 with ground non-metallic sheaths cables into the 3M cable stacker. This consideration arises because the stackers can create conditions where the cables are bundled, leading to heat buildup. This heat can reduce the ampacity of the cables. Bundling of conductors affects their ability to dissipate heat, and this is a critical factor in determining the allowable ampacity. The National Electrical Code, or NEC, provides guidelines on derating conductors in bundled configurations to prevent overheating and potential fire hazards. The NEC addresses conductor ampacity in Article 310. Specifically, 310.15 and its associated tables and adjustment factors are pertinent to understanding derating requirements. When multiple current-carrying conductors are bundled together, the heat generated by each conductor can raise the overall temperature within the bundle. This increased temperature reduces the ability of each conductor to dissipate heat effectively, thereby decreasing its ampacity. Table 310.15 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. These adjustment factors are used to reduce the allowable ampacity of the conductors based on the number of conductors bundled together. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the ampacity must be reduced to 80% of its original value. If there are 7 to 9 current-carrying conductors, the ampacity must be reduced to 70%. The specific ampacity of a 40-2 with ground non-metallic sheath cable is typically rated at 15 amps, according to NEC Table 310.16, assuming it is rated for 60 degrees Celsius. However, this rating is based on the assumption that the cable is installed in a manner that allows for adequate heat dissipation. When 5 to 8 of these cables are bundled together in a cable stacker, the heat dissipation is reduced and the ampacity must be derated accordingly. To determine the appropriate derating factor, one must refer to Table 310.15 in the NEC. This table provides adjustment factors based on the number of current-carrying conductors in a bundle. In the case of 5 to 840-2 cables, each cable contains 2 current-carrying conductors, the hot and the neutral, with the ground wire not considered a current-carrying conductor for derating purposes. Therefore, 540-2 cables would result in 10 current-carrying conductors, and 840-2 cables would result in 16 current-carrying conductors. According to Table 310.15, if there are 10 to 20 current-carrying conductors, the ampacity must be derated to 50% of its original value. For a 14-2 cable with an original ampacity of 15 amps, derating to 50% would result in an allowable ampacity of 7.5 amps. This means that if you are using 5 to 840-2 cables in a cable stacker, you must ensure that the load on each cable does not exceed 7.5 amps to prevent overheating and potential fire hazards. It's important to note that the actual ampacity of a conductor is also affected by the temperature rating of the terminals to which it is connected. Most residential and commercial wiring devices are rated for 60 degrees Celsius or 75 degrees Celsius. The ampacity of the conductor must be selected based on the lowest temperature rating of any connected termination. For example, if a 40-2 cable is connected to a device rated for 60 degrees Celsius, the ampacity of the cable must be limited to the 15 amp value specified in the 60 degrees Celsius column of Table 310.16, even if the cable itself is rated for a higher temperature. Proper installation techniques can also help to mitigate the effects of bundling on conductor ampacity. These techniques include spacing the cables apart to allow for better heat dissipation and using cable stackers that are designed to provide adequate ventilation. In addition, it is important to avoid overfilling cable trees or conduits, as this can also restrict heat dissipation and lead to conductor overheating. The NEC also addresses the issue of ambient temperature, which is the temperature of the surrounding environment. If the ambient temperature is higher than 30 degrees Celsius, 86 degrees Fahrenheit, the ampacity of the conductors must be further derated to account for the increased heat. Table 310.15 provides adjustment factors for ambient temperature. For example, if the ambient temperature is between 31 and 35 degrees Celsius, 88 and 95 degrees Fahrenheit, the ampacity of a 60 degrees Celsius rated conductor must be reduced to 0.88 of its original value. This means that in high ambient temperature environments, it is even more important to derate conductors that are bundled together to prevent overheating. To summarize, when placing 5 to 8 14-2 with ground non-metallic sheath cables into a 3M cable stacker, derating of the conductor ampacity is required to ensure that the cables do not overheat and create a fire hazard. The specific derating factor will depend on the number of current-carrying conductors in the bundle, the temperature rating of the terminations, and the ambient temperature. It is essential to consult the NEC and follow proper installation techniques to ensure that conductors are installed safely and in compliance with all applicable codes and standards. Regarding the permissibility of installing 3-wire non-metallic sheath cable with the stackers, the package quote doesn't explicitly prohibit it. However, caution is advised. 3-wire non-metallic sheath cable is commonly used for branch circuits and typically protected by either a 15-amp or a 20-amp circuit breaker. The stackers are rated for cables up to 30 amps. It's conceivable that using the stackers with 3-wire non-metallic sheath cable could potentially lead to overloading if the circuit's current draw exceeds the cable's derated ampacity when bundled. It's crucial to assess the load requirements and apply appropriate derating factors. The NEC provides guidance on calculating branch circuit loads in Article 220. This article outlines the steps necessary to determine the total load on a branch circuit, including both continuous and non-continuous loads. Continuous loads are those that are expected to operate for 3 IOs or more at a time, while non-continuous loads are those that operate for less than 3 IOs. According to the NEC, the total load on a branch circuit must not exceed 80% of the circuit's rating if the load is continuous. For example, if a 20-amp branch circuit is supplying a continuous load, the load must not exceed 16 amps. This is to prevent the circuit breaker from tripping due to overheating. When using 3-wire non-metallic sheath cable in a cable stacker, it is important to consider the potential for unbalanced loads. In a 3-wire circuit, the neutral conductor carries the unbalanced current between the 2 hot conductors. If the loads on the 2 hot conductors are significantly different, the neutral conductor can carry a substantial amount of current. This can lead to overheating of the neutral conductor, especially if the cable is bundled with other cables in a cable stacker. To prevent overheating of the neutral conductor, it is important to balance the loads on the 2 hot conductors as much as possible. This can be achieved by distributing the loads evenly between the 2 conductors. In addition, it may be necessary to increase the size of the neutral conductor to accommodate the unbalanced current. The NEC provides guidance on sizing neutral conductors in Article 220.61. This article outlines the steps necessary to calculate the minimum size of the neutral conductor based on the unbalanced load. In some cases, it may be necessary to install a separate neutral conductor for each circuit to ensure that the neutral conductor is not overloaded. This is especially important in situations where there are multiple circuits with unbalanced loads. Another consideration when using 3-wire non-metallic sheath cable in a cable stacker is the potential for harmonic currents. Harmonic currents are currents that are generated by nonlinear loads such as electronic devices and fluorescent lighting. These currents can cause overheating of the neutral conductor, especially in situations where there are multiple circuits with nonlinear load. To mitigate the effects of harmonic currents, it may be necessary to install a harmonic filter. A harmonic filter is a device that is designed to reduce the amount of harmonic current flowing in the neutral conductor. These filters are typically installed at the service entrance or at the point of connection of the nonlinear loads. In addition to these considerations, it is important to follow all of the manufacturer's instructions when installing 3-wire non-metallic sheath cable in a cable stacker. The manufacturer's instructions will provide guidance on the proper installation techniques and the maximum allowable load. By following these instructions, you can ensure that the cable is installed safely and in compliance with all applicable codes and standards. To summarize, while the package quote does not explicitly prohibit the use of 3-wire non-metallic sheath cable in a cable stacker, it is important to exercise caution and consider the potential for overloading, unbalanced loads, and harmonic currents. By following the guidelines in the NEC and the manufacturer's instructions, you can ensure that the cable is installed safely and in compliance with all applicable codes and standards. Concerning the use of the stacker on studs less than 2 inches in dimension to satisfy Section 300.4d, it is generally not permitted without modification and careful consideration. Section 300.4d of the NEC pertains to the protection of cables and raceways from physical damage. This section specifically addresses the requirement that cables and raceways be protected where they pass through or are attached to framing members. The intent of this section is to prevent cables and raceways from being damaged by nails, screws, or other fasteners that may be driven into the framing members. Section 300.4d states that cables and raceways must be installed in such a way that they are protected from physical damage. This can be accomplished by several methods, including installing the cables and raceways behind a protective covering, such as a steel plate or a wood board, or by using a cable or raceway that is specifically designed to be resistant to physical damage. In the case of studs, joists, or rafters, Section 300.4d requires that the framing members be not less than nominal 2 inches in size. This requirement is based on the assumption that a 2 inch framing member provides sufficient space to protect the cables and raceways from physical damage. However, in some cases, it may be necessary to install cables and raceways on framing members that are less than 2 inches in size. In these situations, it is important to take extra precautions to protect the cables and raceways from physical damage. One option is to use a cable or raceway that is specifically designed to be resistant to physical damage. These cables and raceways are typically constructed with a thicker jacket or a metallic shield that provides additional protection. Another option is to install the cables and raceways behind a protective covering, such as a steel plate or a wood board. This will help to prevent the cables and raceways from being damaged by nails, screws, or other fasteners that may be driven into the framing members. It is also important to ensure that the cables and raceways are properly supported. Cables and raceways should be supported at intervals that are sufficient to prevent them from sagging or drooping. This will help to prevent the cables and raceways from being damaged by their own weight. In addition to these precautions, it is important to follow all of the manufacturer's instructions when installing cables and raceways on framing members that are less than 2 inches in size. The manufacturer's instructions will provide guidance on the proper installation techniques and the maximum allowable load. By following these instructions, you can ensure that the cables and raceways are installed safely and in compliance with all applicable codes and standards. The stacker itself is not designed for studs smaller than 2 inches. Modifying it to fit smaller studs could compromise its structural integrity and ability to properly support the cables. Any modification would need to ensure that the cable is still adequately protected from physical damage as required by 300.4d. It's vital to consult with local electrical inspectors or authorities having jurisdiction to ensure compliance with local interpretations and requirements. They can provide guidance on acceptable methods for protecting cables in situations where standard installation practices are not feasible. If the stacker is modified, it is essential to ensure that the modification does not create any sharp edges or protrusions that could damage the cable insulation. The cable should be installed in a manner that prevents it from rubbing against any sharp surfaces. In addition, it is important to consider the potential for the cable to be exposed to moisture or other environmental factors. If the cable is exposed to moisture, it may be necessary to use a cable that is specifically designed for wet locations. These cables are typically constructed with a waterproof jacket that prevents moisture from entering the cable. It is also important to ensure that the cable is properly grounded. Grounding is the process of connecting the cable to a grounding electrode, such as a ground rod or a metallic water pipe. Grounding helps to protect people from electric shock by providing a path for fault current to flow back to the source. The NEC provides guidance on grounding requirements in Article 250. This article outlines the steps necessary to properly ground electrical systems and equipment. In addition to these considerations, it is important to follow all of the manufacturer's instructions when installing cables on framing members that are less than 2 square inches in size. The manufacturer's instructions will provide guidance on the proper installation techniques and the maximum allowable load. By following these instructions, you can ensure that the cables are installed safely and in compliance with all applicable codes and standards. To summarize, while it may be possible to use a modified stacker on studs less than 2 square inches in dimension, it is important to take extra precautions to protect the cables from physical damage and to ensure compliance with all applicable codes and standards. This includes using cables that are specifically designed for the application, installing the cables behind a protective covering, and ensuring that the cables are properly supported and grounded.